the parents. Fantastic to have you here, and our amazing young men as well, right? And if you are like me, and if you were around your TV set last night between 8 and 10, I'm sure you would have been particularly excited because, like me, you're probably thinking that we are going to bring it home. I do think so. And I hope you can give a thumbs up in the chat if you think we are going to bring it home, boys. Um, and one of the things that I hope that will happen is that grand, fantastic celebration in the end when we have finally brought it home. And one of the things that we're going to use to celebrate, I hope, are fireworks. So that brings me to my topic this morning, fireworks and rainbow flames. Interesting. We're going to dissect what we mean when we look at fireworks and rainbow flames very, very shortly, boys. But like me, I'm thinking that as young scientists, you're probably asking, I mean, those spectacular lights that go off when the firework gets launched into the air, that explosion, the reds, the blues, the yellows, the whites, how are they formed? Why are they there? How could it be done? So we're going to look at all of that today, gentlemen. And we're also going to look at an amazing experiment that can take the principle that I'm going to explain to you and show you in the real world. So just a little background, gentlemen. We probably know that the Chinese were the ones who were credited with the invention of the fireworks. And what they are, gentlemen, they're simply powders that are wrapped in a cylindrical object and it's launched into the air, and after the explosion there's this grand display of color as you are seeing on my screen right now. But boys, the question is, that powder that you're seeing there, it's called a salt. All right, they're called salts. And if you realize, gentlemen, that the salts, it's pluralized. So I know that we're familiar with the sodium chloride that's on our dinner tables. That's the most common salt that we know. But the fact that I have pluralized the word salt suggests that there are many types of salts. So that's what we're going to talk about before we get into the experiment. But before we even go to defining what a salt is, gentlemen, what I want you to do, you're probably sitting on a chair, you're probably sitting in your living room at the moment, there's probably a radiator, your chair probably has some metal on it. What I want you to do, gentlemen, I want you to take a quick look around your environment and identify as many objects as possible that have metals on them. And then, gentlemen, you're going to use the chat function and you are going to just give me that object or two objects if you found them that are made of metal. So I'm going to give you a minute to do so, gentlemen. And then when I count down from 3, 2, and to 1, we'll get back to the rest of the lesson and we will press on with finding out what a salt is, how a salt is made, and then to our amazing experiment. So off you go, gentlemen. Just a minute, and then you will meet me back right here when I've done my countdown.
Thank you, Mr. Russell. While we're waiting for a few responses from the boys, just a quick announcement, gentlemen. We thrilled England won last night, so well done. But let's focus now and respond to Mr. Russell's questions on the science experiment. I am telling you, you will be thrilled. Thank you.
Right, Mrs. Ayodele, I'm sure the responses are coming in. So, gentlemen, I'm giving us 10 more seconds to wrap that up, and then we're going to continue. We are at about 7 seconds now.
I can tell you a few of the responses here, sir. Some are having bike. I can see a lot of wonderful responses from this amazing scientist. I can see laptop, I can see radiator, I can see door handle, I can see TV, and that's wonderful, gentlemen. So I'm going to mute myself back now and just leave Mr. Russell to carry on. Thank you, sir.
All right, thank you, Miss. Those gentlemen, those young scientists, thank you so much for your responses. Those are brilliant responses, gentlemen. So, the other thing I'm going to ask you to do now that you are back at your seat, you're going to use yourself as the example now. So what I want you to do, gentlemen, I want you to take your right hand and you are going to place it on your abdomen, just below your rib cage on the left side. So you're going to take 3 seconds to do that. So in 3, 2, 1, brilliant, gentlemen. So our hands would have been just below our rib cage on the left side of our abdomen. And what you have just done, gentlemen, you have just located your stomach. We're talking about fireworks and rainbow flames. So that's sort of odd that Mr. Russell would introduce the stomach in all of that. Your stomach contains a really, really strong acid that we call hydrochloric acid. That's in your stomach, and it's responsible for killing all the bacteria that might be on the food, and it is also responsible for breaking down the food. But why have I mentioned acid in your stomach when we're talking about fireworks and salts? When you're making a salt, gentlemen, you take a metal, just like the ones that you had located, and you take an acid, just like the one that's in your stomach, and you combine those two together. And the resulting product is what we call a salt. So really well done, gentlemen, on identifying those two things. Take a moment to absorb this definition of a salt. When we combine a metal and an acid, the product is a salt. All right. So, gentlemen, while you're thinking about that, just go ahead. I know we have some brilliant scientists in year 7 coming in. So what I'm going to ask you to do, gentlemen, if you know an example of a metal, if you know an example of an acid, I'm just going to ask that you type that in the chat, and you are going to send that through in 3, 2, 1. I'm giving a minute for responses. You will see a green circle filling up. When the green circle is finished filling up, Mrs. Ayodele is going to share 1 or 2 of the responses that our brilliant gentlemen would have given us as an example of a metal and an example of an acid.
I'm still looking on the screen, sir. As soon as I hear this, yes, I'm still looking on the screen, sir. I think there's a bit of delay with your comment. So as soon as something comes up, sir, I will definitely read them.
Absolutely. Thank you so much for that, Miss. I know our young men are thinking about it very carefully before they reply, but I'm certain that the replies will come through. One example of a metal that you know, and one example of an acid that you know. Right, so our minute is up, gentlemen. Mrs. Ayodele, are you seeing any responses from our young men?
I've seen a couple of responses, but I'm looking at it. I can see, is this something to do with lemon, sir?
Yes, there are acids in lemon.
Nitric, I can see acid. Iron, I can see binary acid, I can see nitric here.
Those are brilliant responses. So our young scientists know their acids. This is what it's telling me. Our young scientists coming in, Mrs. Ayodele, they know their acids, they know their metals. So that's really well done to those gentlemen. Absolutely excellent. So, boys, just give this a try while we talk some more about our salts. Now, we said that a salt contains a metal and it contains an acid as well. Now, the metals that are in those salts, they have what we call atoms inside of them, and these atoms can absorb a lot of heat when heat is applied to them. Now, can you imagine, gentlemen, a baby that you've just fed? They would take in the food, which is a form of energy, and then they would be hyperactive for a few minutes, and then they'd probably go to sleep because they're tired after that. Think about your atoms in the salts like that. They will absorb all of that heat energy, but they can't keep it for very long. So when they are giving out the energy that they absorb, they don't give it back out as heat. This is a really interesting part. They give it out as light. So gentlemen, you would have been looking at this and you would have noticed that all salts contain metal atoms, and everything that I've said here, except the one that I've circled for this second one, is something that contains a salt. So bleach contains sodium chloride. We're going to learn about that when we get into the labs and we start doing our experiments in year 7. Gunpowder contains potassium chloride. We're going to learn about that again when we're doing our experiments in year 7. And the grit that we put on the ground when it is snowing or when it is quite icy, that too is a salt. That's calcium chloride, gentlemen. But again, we're going to learn about all of this when we get into school and we start doing more amazing experiments. So, gentlemen, the color that we see when fireworks are being displayed depends on the metal that gave out the light. So different metals will give out different colors of lights. So if you're looking at my screen right now, gentlemen, you're seeing a few metals. What we are showing here are the symbols for those metals. So like strontium here, it's a brilliant red. Calcium will always give off a bright orange light. Sodium will always give off a bright yellow light. Barium, which is Ba, will always give off a bright green light. And also copper, which is a metal on our periodic table, will give off a brilliant blue light. So gentlemen, depending on the metal that is in the salt, the color that you see is going to be very, very different. Now, what we're going to do, gentlemen, we're going to switch over to an amazing experiment. So in a few seconds, Mrs. Ayodele will switch from the PowerPoint presentation and actually go live to a video feed. And you will be looking at one of the lab spaces that we have here at Harris Boys. Excellent lab space for you to work, very well equipped, lots of experiments to do, lots of things to do. Our very knowledgeable technician is also going to be with us during this experiment to guide us through. So what we will be doing, gentlemen, we will be measuring out 7 salts. Remember I said that we don't have one salt, we have many salts. So the salt that you're used to that you put on food, that's just one type of salt. There are other salts out there, right? So we're going to measure out 7 of those salts. We're going to add each of them to a glass beaker. So I'll be showing you the equipment as we go through as well. We're going to pour a mixture of water and ethanol on them. And then, gentlemen, we're going to ignite them, turn the lights off, and you will see something absolutely amazing. So I think Mrs. Ayodele is going to switch over now to the live video feed so you can actually see myself and my lovely lab technician go through the experiment.
Yes, Mr. Russell, if you can come on board, sir, because I can still see you, but just with your PowerPoint, if you can switch the camera to yourself, and I can bring that live for our young inventors and our young scientists to see as well.
Our brilliant Mrs. Ayodele, I am going to do that just now. I've just unshared my presentation. So,
waiting for you to come on board, sir. I can see your name there, waiting for your face. Just wait patiently, gentlemen. Mr. Russell is trying to switch, and you will be able to see him shortly. Are we okay, Mr. Russell? So while we're waiting for Mr. Russell, gentlemen, to switch over, could you just put on the question and answer area what you've learned so far from this science session, gentlemen? If you can type that there, please, that would be amazing. And that gives Mr. Russell a few seconds to switch from the presentation to himself. Awesome. I can see your classroom now, Mr. Russell, and I've clicked on that now. And I'm gonna send you amazing lab live. Boys, can you just put on the chat for me, please, if you can see Mr. Russell's lab, please. Thank you. And I can see Mr. Russell trying to come behind the table where he's gonna perform the experiment. Brilliant. Over to you now, sir. We can't hear you, sir. If you can bring your camera closer so that can catch your voice and we can hear you nice and clear. So while we're waiting for Mr. Russell to sort out the sound bait, you can just, fantastic. I can see a couple of people can say it. Brilliant. I can see from a couple of students, I wouldn't want to call your name now, but I just want to say, well done. Yes, awesome. So they can see our wonderful science experiment room. Our lab is there ready. And Mr. Russell is going to take you through performing this wonderful flame experiment, and he's going to talk you through it. So while we're waiting for that, just put on the screen for me in the chat what you've learned so far about the different type of acid, about the different type of salt that Mr. Russell has taken us through this morning, while we gently wait for Mr. Russell to come around the camera and talk us through this wonderful experiment. So he's back now. Over to you, Mr. Russell. Sir, I think you need to check your volume. We still can't hear you. Your volume was clear earlier. You can just say hello, then we take it from there, sir. Thanks for your wonderful patience, gentlemen. Mr. Russell is trying to sort that out. I think because they moved the camera, that is causing a bit of issue, but that's fine. But while we're waiting for Mr. Russell, gentlemen, you can just type, okay, Mr. Russell is back on now.
All right, can you hear me now, Mrs. Ayodele?
Yes, we can hear you loud and clear now.
Brilliant. Excellent. So I can get on with the experiment now. Thank you so much for your patience, gentlemen. Right, so as I said, each salt that we make, gentlemen, they have a metal in them. So what we're going to do, we are going to pour each salt in its own beaker. We are going to add some water. We are going to then add some ethanol. We probably know ethanol as being our rubbing alcohol that you can rub on your arms or on your head if you're sick. It's the same sort of ethanol that we're using here. So as we pour our salts, gentlemen, pouring our salts. As we pour our salts, gentlemen, you can begin to think about some of the possible colors that you are going to see once the flame has been ignited and once the lights go out. Right. So we have added all our salts then. We're going to simply take some regular tap water and we are going to dampen our salts. And gentlemen, you can probably think of why we need to add some water to this. Think about your salts and your sugar. When you add water to them, what exactly happens to them? So we've done that, gentlemen. Now we're going to go and we're going to add our ethanol. So we're adding our ethanol then, gentlemen. And my lovely technician, you will meet our technician. She's absolutely brilliant. She's assisting me with this. And then once we're done pouring our ethanol, gentlemen, then we're going to start the spectacular bit. We are going to ignite the flame. Adding your goggles for safety, of course, gentlemen. Lighting our splints. And now, gentlemen, you are going to observe something absolutely spectacular as each of these burn. So as each of these burn, gentlemen, I hope you are currently seeing the different colors that are being given off by the different salts because they contain different metals in them. Remember earlier I said, gentlemen, that the flame that we see depends on the sort of metal that is in our salt. So at the moment, gentlemen, you should be seeing, as you are going across, something red, something blue, something orange, something green, which are all things that you probably see if you are looking at a firework. So take a moment, gentlemen, make note of these brilliant colors that you're seeing, because after we're finished with this experiment, boys, what we're going to do, we are going to try to identify the actual metals that we're seeing based on the flames that you're seeing here. So boys, if I could move my camera just a little bit closer.
Wow, this is wonderful, Mr. Russell.
It is this, and boys are really enjoying the real see because it's absolutely spectacular to see. So, gentlemen, as the experiment winds down, so we saw quite a number of colors then. So as the experiment winds down, gentlemen, what I'm going to ask Mrs. Ayodele to do, we're going to ask her to just switch back to the main PowerPoint presentation. I'm going to reshare this.
Thank you so much for that, Mr. Russell. Would you like me to switch over to the PowerPoint now, sir?
Absolutely. I would love for you to switch over now, miss.
Over to you now, sir. I'm sending your PowerPoint live, sir.
Oh, brilliant. Thank you so much, Miss. Now, as we wrap up, boys, what I want you to have a look at, I want you to have a look at the bottom of your screen, and you're seeing some flames with some colors as well. Now, gentlemen, those colors that you're seeing, think back to the experiment that you saw just now, and think about the colors that you saw when the lights went out and the flames were lit. What you're going to do next for me, gentlemen, you are going to have a look at this chart that we have here. Each color on the chart represents the characteristic color of certain metals when they burn, meaning those metals will always show that color when you burn them. Now, if you realize each color makes out particular letters. So like we're looking at the reddish orange one at the top left, and that forms out the letters Li, right? So if in your experiment you saw something that looks sort of red, what you can do, you can write down the symbol because the symbol is colored in red. If you saw anything green, you can write out the symbol that's colored in red. If you saw anything yellow and anything orange, you can write down the symbol that has that color as well, right? If you saw anything blue, you can write down the symbol that had that color as well. So I'm going to give you a minute, gentlemen, to think about that, and then we're going to move over to our closing activities. And if we have time at the end, I will take a question or two from my brilliant young scientists. So just a minute, gentlemen. When we're nearing the end, I will do a countdown from 3, then 2, then 1, and I will ask you, gentlemen, to share some of your responses in chat, and then we move on to our final activity.
Thank you, Mr. Russell. I am seeing a lot of wonderful comments from our young scientists. A young gentleman said, wow, the flame experiment is cool. Such a wonderful expression of joy and, thrilling session with you, Sam. Thank you.
That's brilliant, Miss. I'm happy that these young men are really enjoying the session, because that is what science at Harris Boys is going to be like. If I have my own way, I'll turn all the boys into scientists, but I know that there are other specialties like Spanish with yourself, Miss, where I'm sure the boys will do absolutely brilliantly in. Right, so we're winding down our minute now. So our minute ends in 3, 2, in 1. And so, gentlemen, this is your final activity. The letters that you wrote down, each letter represents a symbol, and each symbol represents an element. Now, all the elements that we know of in the world, we can put them in order of how heavy they are, and there's a particular table that we can put them in that we call the periodic table. So what you're seeing here, gentlemen, is just a small part of the periodic table that we use a lot in the sciences. Your task now is to find the symbol that you wrote down and match it with the name that is below it. When you do that, boys, you would have found the salts that we use, the metal that is in the salts that we use to do our flame experiment. So if I should repeat the task once more, you're finding the symbol on the periodic table that you wrote down. The name for the symbol is below it. Now that name that you will find, that's going to be the metal that was in the salt that we used in the experiment. So once you find the name, you would have found the metal in the salt that we used in the experiment. I'm giving you, gentlemen, 2 minutes, just 2 minutes to find all your symbols and what they mean, and then you are going to share a few in the chat with Mrs. Arabelli, and she's going to tell me what they are, gentlemen. So my brilliant scientists, 2 minutes, go.
Would you like me to read some of the comments, sir, or we should just give them 2 minutes and then we take it from there, sir?
If some of the boys are sending through their comments already, absolutely go ahead.
I'm not new yet, because you need to take a couple of seconds to get their comments. What I can see is young men that are saying, oh, the experiment is thrilling. They're talking about that green is copper, and they're talking about the different colors. And one said, I don't even know we have different type of salt, which is great. But I'm gonna wait for their new comment, and I'm gonna read that out aloud. Thank you, Mr. Russell.
All right, thank you so much, Miss. While we wait, Jet, I'm just impressed by a young man who had mentioned that the blue from the copper. So he has identified something already, and the other gentleman who said that he didn't know that there were different types of salts. Yes, they are, and I'm really happy that we're able to shed some light on that. That is what science is all about, gentlemen, finding out new things about the world around us, trying to explain phenomena, putting things into context, as Miss George had said in her English language presentation. So excellent, gentlemen. As your answers come through, we will take them because the 2 minutes is almost up. At the end of the 2 minutes, I'll do a simple countdown from 3, and then we can share some more responses. All right, excellent, gentlemen. So we are winding down now. Just about 10 seconds left to type in your last few responses. Five seconds left. And 3, 2, 1. Right, so Mrs. Ayodele is going to share some responses, but I'm also going to bring up the answers. So you're looking for that purple circle around the symbols and their names. All right, so these purple circles represent all of the metals that we used in the experiment today. Right, so while Mrs. Ayodele share, gentlemen, you can go ahead and confirm that you found these ones that are circled.
Thank you, Mr. Russell. I am looking at the comments now and seeing there's a bit of delay in some of them coming up. The one I can see now are the previous one, but if you can check your screen as well, and if you can see some, so we can read the comments out.
All right, brilliant. Will do, Miss.
I still have here, green is copper, lithium was 1, copper is yellow.
All right, excellent, Miss. So I like those responses. So just to wrap up this bit, gentlemen, lithium. So let's go now. The red one that you saw, that was lithium. If you saw something that was brilliant yellow, that was sodium. If you saw something that was blue, that was magnesium. If you saw something that was brilliant orange, that was potassium and calcium. And if you saw something that was somewhere in between blue and green, that's the last one at the bottom there. That's barium, gentlemen. Now, over the summer, I would love for you to take the opportunity, boys, and get used to this table that we call the periodic table. It's one of those foundation things in science that we're always going to refer to when we are making when we are drawing conclusions, when we are discussing things. We will always go back to our periodic table. So if you can get on top of that now, it would be absolutely brilliant for you when you get there in September. So, Miss, I am just going to end with a question for the boys to ponder. Remember that stars and the nebula, they are billions of light years away, but scientists have been able to tell what exactly makes them up. So based on what we have discussed today, boys, about each element having a characteristic color when it burns, think about how scientists are able to determine what the composition of stars and nebulae are even though they're so far away. So while you think about that, gentlemen, thank you so much for today's session. It was absolutely a pleasure to show you this fantastic experiment. Some of you have said that you really enjoyed it. I'm happy that you enjoyed it, boys. And I look forward to seeing you when you get here in year 7. So thank you, Mrs. Ideli, for having me do this presentation. Our awesome boys are here. It was a lovely experiment. And I'm sure you'll have a lovely rest of the afternoon, because I know your pet subject, Spanish, is coming up.